2022 webinar series. My name is Satwinder Paul. I'm a teaching professor in the Water and Wastewater Technology program, and I'm also the co-creator of this online help center website for BC Small Water Systems. Before we begin, I would like to recognize that Thompson River University campuses are on the traditional lands of the Tk'emlúps, Secwépemc, Kamloops campus and the Tiksalak Williams Lake campus within the Secwépemc Ulu, the traditional and unceded territory of the Secwépemc people. Thompson River University, with their partner, hosts an annual webinar series and courses dedicated to providing relevant technical information, resources, and tools to small water system owners and operators and First Nations small water systems on issues of treatment, regulations, operation, maintenance, and water quality monitoring. At the same time, we hope to also provide a forum for systems to share information with one another. The Online Health Center strives to assist all small water systems in BC to implement a multi-barrier approach to drinking water in order for systems to consistently provide safe, potable drinking water to their communities in compliance with government regulations. The webinars are scheduled for every 2 months in 2022 and is offered free of charge for all attendees that register into our webinars. For attendees who are EOCP certified operators, each webinar will count as 0.1 CEUs towards certification. A certification of completion will be issued to the webinar participants, which then can be submitted to EOCP for your CEUs. We will have our 1-hour presentation followed by half an hour of a question period. During the duration of the presentation, if any questions arise, please jot them down in the question section just above the chat box. And then, of course, we will do our best to address those questions after the presentation. So let us begin our webinar, and I'd like to introduce Blaine Matuga, Blaine Matuga, my apologies, for today's webinars on well operations and maintenance best practices. So regular well maintenance is an important part of small water systems operations. Proper maintenance preserves the lifetime of well infrastructure and prevents risks against groundwater contamination and ensures the safety of drinking water. In this webinar, we'll cover the following topics: inspection of well components and equipment, measuring and troubleshooting well performance, for example, water yield, checking water levels, pump test requirements, and specific capacity. We'll look at pump motor performances, water quality testing, and record keeping. So I'm very pleased to have Blaine take some time and do this webinar for us. Blaine is the president of Central Interior Pumps Limited. He's a level 1 and 2 certified pump technician and has been in the water industry for over 24 years. He's the past president of the BC Groundwater Association and is an advocate in getting the Canadian Groundwater Association back up and running. Blaine works closely with First Nations, engineers, and municipalities in providing safe water and educating water users. He's an ambassador in promoting the protection of groundwater, with his company using Protector of Groundwater as their motto. So welcome, Blaine, and we're looking forward to your presentation.
Good morning. First of all, thanks for having me, Satwinder, to put this on here, and I hope everybody is able to get something out of this, and we're just one more question, Satwinder. It's not showing my screen right now. I think. I think we're up and running now. Okay. Yeah. So I think everybody can see our first screen. If anybody has any issues or whatever, they can also put something in the chat box, and then we can address that situation as well. So I'll start off here first. So again, as Satwinder said, this is well operations and maintenance best practice. My slides aren't moving. Oh, here we go. Just a second. Yep. Okay. So BC legislation, let's start off. The groundwater protection regulation ensures that activities related to wells and groundwater are performed in an environmentally safe manner. Under the WSA, the groundwater protection regulation regulates minimum standards for well construction, maintenance, deactivation, and decommissioning. Recognizes the types of qualified people certified to drill wells, install well pumps, and perform the related services. So as stated, the certified to work on a well, we have to be certified as a well driller, a well pump installer. So constructing and decommissioning wells, installing well pumps, disinfecting wells, and conducting flow tests are restricted activities that can only be performed by a certified well driller, well pump installer, or a professional, or working under a professional engineer or geoscientist. So best practices is well maintenance. Long life and maximum production, you can't have one without the other. So we created this slide. It's called the water well life cycle. And if you see under the water well life cycle, we have to get the actual started of where we're going to put the well. And it's the life of the well that we have to work with. So, we look at the first there where you've got the 3 round circles, we've got the drill, the flow test, and then the pump set. But this is just the start of this well, and we've got a lot of years that we want this well to perform at its best, and usually it's performing at its best is when the well is first drilled. So pump company to assess the volume required and estimate pump size to lift the water from the target depth. The drill company has to give the pump company some idea of how much water is available, and the pump company to flow test the well. And then the pump company to set the permanent pump in place and then run a short flow test to make sure what we've got. And then, as we'll be talking about, is installing a tube in the well that we can put a transducer in that well to be able to monitor the well for the life of the well. And then at the end of the equipment going in, the pump company needs to do their due diligence and do a small chlorination on the well. The big thing about this whole life cycle is that we follow a procedure so that anybody that comes into this well for later on down, that we're able to have proper record taking so that we can give the next engineer or geoscientist on how we're going to keep this well at its best performance. The one thing that we all know, and we'll have it in the next slides coming up too, is that usually well life is determined by how much money you want or that's available to be able to work on this well in future. And that's not just money that's set aside for the pump change out. It's more to do with the well servicing. So on that, on the page 2 there, it says well servicing, pump company to advise the drill company of a problem. Go back to the original records. As you know, we have turnover of the people that monitor the system are going to change hands. So we want to have good records to make sure that we can give these numbers to the geoscientist or engineer so that we can work with the companies together to be able to service as well. So the depletion is usually what we first look at, and then we look at depletion by what may possibly look at the well records, and it's showing that the well the flow is going down. So that's part of that depletion ends up being part of the biofouling that happens within the well. This could be either a screen problem or in your aquifer problem. And so the to try and get this back to where we need it to be, we're gonna carry on with doing some rehab on this well. So great slide. Hopefully you'll be able to use it in your future. So why wells fail? Pumping test was not performed. Specific capacity at time of drilling was not recorded. We'll get into that. Pumping is not efficient, so that means that the pump might be too big, or and we're actually drawing the well down too hard. Improper lack of well maintenance, which means a lot of times insufficient funds. Water analysis information is misinterpreted, because a lot of people, when they get their water analysis, they're looking at the quality of the water and not realizing that those actually give us a lot of information on how to move forward onto how we're going to work to rehab this well. So then a combination of all the above. So construction of well. Well driller, professional, or other people responsible for constructing a well is required to comply with the provisions of the groundwater protection regulation related to how the well is constructed. So it comes down to, again, that do your due diligence and make sure that you're hiring professionals to do the related work to construct this well. This person must ensure that the well meets minimum standards for the well casing material, wellhead completion, which is becoming bigger all the time due to not having proper things done. Surface seal, well caps and covers are maintained, and the well identification, which gives us a lot of information moving forward. And the person must also submit a well completion report to the province at the end of after the well has been constructed. So this simple diagram here, if a well is inside your is actually inside your pump house or inside of a building, you have minimum requirements. These all come down to what the well looks like from the from the bottom of the well screen to the surface. These all need to be in place to make sure that we protect this well. And so that we have the proper surface seal, that we don't have contamination down the well. So a well cap sounds simple, but if it doesn't have the proper things like a rubber gasket that fits tight onto there, it allows for spiders and bugs and different things to get in there. So if you look at this one, this is more of what is, whether it's commercial or residential well. It's going to have something that's going to keep it from the water line from freezing. So that's going to be the pitless adapter. So our water comes from our pump out of our well up to that pitless adapter and into the main line and out to your treatment system. All parts of it, you know, from the pitless adapter to the borehole to the casing to your annulus, the formation of the seal down where the screen is. Just below the pump is we have what's called a K-packer that seals from the casing to the screen, and then we'll have either a confined aquifer down at the bottom where our screen is. Again, that's what your typical well cap for residential or some commercial wells will have. So this well ID plate must be attached, and if it gets knocked off, you must replace it as part of compliance. And the government will issue a new plate, so you'll have records that show what number your plate is, and they'll give you another plate. So this, again, this shows the pitless adapter. It's very simple. It's just a mechanical device that's attached to the side of the casing that can slide in and out for removal of the pump, or for if we need to remove the pump and all the gear out of there to do a rehab on the well. Again, 4'8". In some cases, this might be down in Vancouver, but if you go up north, you're probably looking at 6 to 8 feet. And this allows us to get the gear out of the hole. So the well casing, is drilled into the ground, pipe or tube installed into the borehole, separating the well from the surrounding material, and it prevents the walls from collapsing. Again, this is in what we call an overburden well, so it's more of gravel, sands, silts, not in a rock hole. And this steel casing would be drilled into the ground using different types of drilling methods, but it all ends up being the same, that we're going to put this screen at the bottom of the well where we're going to get our water from. So, and there's our screen, what it looks like if you haven't seen one before. It's a whole bunch of slots. Those slots prevent the gravel from coming into the well, and keeps the water flowing in into it. So a big problem that we have, especially old wells, they weren't sealed. The annular seal was not sealed properly because the old type of drilling wasn't used a proper seal. So what happens after a lot of times, our borehole will be drilled, and then we'll start seeing these pockets form around the outside, which allows for contamination along the seal, where the seal should be, and following water that's contaminated from the surface to enter our annular space, which can cause contamination in the well. So it's terminology here. What we'd like to see most people use, because this terminology goes a long ways when you report your findings. And this sometimes is used more at the beginning than in your daily workings. But the static water level, the level of the water in the aquifer before any water is drawn from the well. So that water level it gives us a huge amount of information right off at the beginning after the wells have been drilled. So then the pumping water level, after we install the pump, is the level of the water in the aquifer when the water is being drawn from the well. And we have to determine that so that we don't go past our drawdown of our well and affect a well and the pump. So it's so the drawdown, the difference between the static water level and the pumping level. Pretty easy diagram to follow. And we do that. We use those numbers a lot when we do a well test. So the well yield is the rate of water withdrawing that the well can supply over a long period of time. The yield of small wells is measured in liters per minute or gallons per minute per hour or per minute. For larger wells, it's measured cubic meters per second or per hour or gallons per hour, or in cubes per hour. A measure of volume of water extracted from a well per unit of time, and usually measured over a long period of time. So those record takings that you all do, keep up with those, because it goes a long ways when we start working on to go into having to rehab this well. So the recharge rate, the rate at which an aquifer is recharged after or during pumping. If the pumping exceeds the rate of recharge, the well will eventually run dry. Shallow wells are more susceptible to the environment, of what's going on in the environment, but deep wells can end up being a big problem for long-term use. So getting to what we do when we do a well test, which is the most important thing at the start of the life of the well, to be able to determine what we're going to put in for a pump. So we do this by what's called specific capacity. So a measure of well yield per specific unit of drawdown. So specific capacity equals the well yield per drawdown. So measured as gallons per minute of foot drawdown or liters per minute meter drawdown. It is used to measure the pump and overall well performance. When a well screen plugs or the pump begins to wear, the specific capacity may be reduced, and that's for sure. So when we go in to do a pumping test, is a method of estimating well performance, well capacity, the zone of influence of the well, and the aquifer characteristics. The aquifer's ability to store and transmit water, aquifer extent, presence of the boundary. It helps to determine the maximum yield from a well, assesses the impacts of neighboring wells or water bodies. Attain aquifer properties such as permeability and boundary conditions. If we don't get this information right at the beginning, we can affect a lot of people's wells that are in the area, as well as yours if we don't get the information from other wells that are also in the area. So we may go into a well test and perform the actual drawdown test on the pumping well, but we'll also take measurements from other wells that are in the area to make sure that we're not impacting the other people's wells. So simple graph. We start at the top here. So if we call that the top of the well where it says pump startup, but it's not actually where it's the actual original static water level that we a lot of times get from the driller at the beginning, and we figure out how far we're going to be able to draw down the well. So if you look at the bottom number, or the bottom where it says recovery and the hash marks there, our pump is going to be set below that. Typically we try and always keep a buffer of about 3 meters below that number. So we turn the pump on. It's based over an elapsed time, and we start to draw the well down through different sets of what the well possibly could produce. And we'll run that for a period of, if it's a quick test, it'll be a 24-hour test. If it's a long test, 72. We've tested a lot of wells even longer than that, especially if there's high impact on this well. Big commercial wells we'll test for days on end. And then at the end, where it says where the pump shutdown is, we also measure the recovery rate from the time that the pump is off till up to 90% of recovery, back up to where we first started the pump. And that is where we have to start off with all our new wells when we put in a new well, more in a commercial application, but because it costs so much, residential wells don't get this much effort put into them. So pumping tests in a confined aquifer. So we put in what we call a sacrificial pump. It's not the pump that we're going to use for the long term of this well. So use a temporary pump, groundwater's pump for 24 hours. In a confined aquifer, and 72 hours for a well in an unconfined aquifer. That's a little bit misleading in that we are working usually under a geoscientist or an engineer, and it's up to his determination on the impact of the well. So a confined aquifer requires less pump time because pumps in a confined aquifer generally provides a constant head pressure, allowing for constant pumping properties. We just don't want to have the bathtub effect. So depending on the engineer, and the bathtub effect is you pull the drain, which ends up being the pump, and we pump it down, and we don't have a long recovery rate, or we have too long of a recovery rate. As soon as a well flow has been established during a pump performance test, in theory, it will continue as long as the supply continues or is replenished. So pumping test in an unconfined aquifer. An unconfined aquifer rely on gravity to replenish the well. When a well's situation in an unconfined aquifer begins pumping, a cone of depression is created, changing the head performance on the pump. This in turn affects the pumping performance. To ensure that the aquifer has been sufficiently challenged, pump tests are run for long periods of time. So that cone of depression on the couple slides back, it'll always create this huge cone that comes down from where the pump sits at the bottom. that'll always kind of work its way down, and then as the cone of depression starts to bring down, that's our pumping level. So that's our pumping rate. So prior to performing a pump test, it is important to anticipate a proper, appropriate pump flow. Over pumping will increase the drawdown beyond the capacity of the aquifer, and the pump test will fail. So we want to tax the well, but we also want to make sure that we're not overtaxing the well. So we want to bring that level down to where it starts to stabilize out, and then we start to assess that we have enough water replenishing into that well that we can move forward with construction of the well. So well performance monitoring is performed to evaluate the well efficiency and to assist in identifying any potential problems. And we can't do it without doing a pump test. Deterioration in well yield could be a result of an insufficient pumping. So we're over pumping the well, taxing it too hard when it's been constructed, and then plugging off the well intake area and reduce production from the aquifer. To assist in identifying the onset of cause-of-deal problems, well performance tests can be conducted periodically to determine if there are any changes. So before I carry on, we will do, if we have concerns after we do our specific capacity tests after 5 to 10 years, we like to see it closer to 5 years rather than 10. We want to do a well test. So we can do a well test with the pump installed, or if the engineer wants to see if that drawdown is really getting bad, we may have to pull out the gear and start with a new pump. So drawdown, which is the difference between the initial non-pumping water level and the pumping water level at a specified time interval. Overall production of the well over the long term. So we want to get those numbers so that we can see any changes. So the results from these tests are then compared to the baseline data recorded when the well was first installed. Proper trending will provide good information and will aid in any decision making over the life of the well. If this baseline data is not available, periodically testing should commence immediately to accumulate data for future comparisons. This is where we promote huge on having data loggers in wells or level loggers in well to determine what pump off time and pump on time, and measure to see how far this well is actually drawing down. So aquifer performance evaluation. Aquifer performance evaluations are necessary to establish the long-term yield of an aquifer, should be conducted on a routine basis, especially after any changes of equipment or installation of additional wells in the same aquifer. And your pump guy that pulls this well has a lot of information when he pulls the gear out of the well. He's going to see for biofilm film on the outside of the pipe, or on the wells, the pump screen. Equipment has to come out of the well, so that you do, you watch for those things. So water level monitoring. As I was just saying, the best way to watch the water level monitoring is through data loggers. They're quite easy to install, and for most part, they're not that expensive. So record water level measurements on a regular basis. So non-pumping and pumping water levels should be taken at least a monthly basis. If you don't have a level logger inside that well, hopefully you have a tube in there that you can use it, what we call a dip tape, and the dip tape goes down, it's just a sounder, and it goes down and it tells you what the static water level. So changes in the non-pumping level, static water level may signal these possible problems. Aquifer depletion, changing the pumping level may indicate a possible decline in well performance as a result of screen plugging. It also determines how long your pump is on time and off time. It makes a huge difference, because off time can also indicate, or may not indicate to you, that there's a problem in the well because the pump is actually off too long, and that static water level comes back to the original level. So you got to be careful on that. It's run on a bit on your intervals of your regular pumping. So best time to measure the static non-pumping water level is when the pump has been resting for quite some time. For instance, early in the morning prior to any water use. So again, this is to do with that on time and off time. Make sure that you follow, you know, if say your run times are 15 to 20 minutes or something like that on a regular basis, you can just tell by what the meter usage is, or calculating how long it takes to fill your reservoir. Make sure that you keep it off for 15 to 20 minutes longer than that was, to see if that static water level comes back up again. So ensure that the pump is shut off until the measurement is completed. If the pump has been running, wait for at least 15 to 30 minutes to allow the water level to recover before taking a measurement. However, in a low permeable aquifer, the recovery takes several hours, and that's when you know that you may have issues. After taking an initial measurement, wait for another 15 to 30 minutes and measure again to ensure that the water level is stable and is actually the static water level. So you have that static level at the beginning. Let's make sure that we try and go back to that again. The pumping water level is recorded while the well is operating. So again, we need to know where the pump is so that we're not pulling that and causing, you probably have heard of cavitation, that we're not causing cavitation down in that pump, and that we're back to those pumping levels when we first installed the gear. Any further measurements should be taken after 30 minutes of pumping. If the discharge rates are the same but the pumping water level has decreased, then plugging of the well intake may have occurred. Specific capacity method. The specific capacity method measures the well yield per unit of drawdown. This method does not provide aquifer performance analysis to the same extent as do the drawdown or recovery method. The specific capacity method is useful for comparing production information of an aged well to production information of the same well when it was new. Again, huge information to take all those numbers down and compare them. So again, as I said before, specific capacity is an assessment of the productivity of the well and is defined as a well yield per unit drawdown, imperial gallons per minute per foot of drawdown. This translates into the amount of water level drop in a well at a designated pumping rate over a specific time interval. So time off, time on, and then pumping rates. Specific capacity should be measured when the well is new or when new screens have been installed. It's really tough to do specific capacity before the well screen is installed. We usually do it right after the screen has been installed in a new well, or during a pump test. The specific capacity will change throughout the year with fluctuations in pumping rates, temperature, aquifer levels, and degree of screen efficiency. And not for all wells. Like that can be in shallow wells, can be in deep wells. So every well can act different. A drop of 5% in specific capacity indicates problems with a well. We've seen wells at 3% started to show problems. Now this is on a very large system. They were pumping at over 1,000 gallons per minute. They noticed it right away because the 3% in 1,000 gallon per minute well is a huge number that they're losing. So they want to catch it right away. So catching the problems at an early stage gives us the best chance of well rehab. So specific capacities are a huge, like I said, are a huge number to us. We spend a lot of time with this, working with the engineer or geoscientist to make sure that we, and more than likely, if we're getting specific capacity numbers, we're back to those level indicators that we need installed in the well. So again, as in our slide shows. So when and why to establish your well baseline? Establish the baseline right when the well is completed. We want to get these wells drilled and installed as soon as we can. I know it's tough. The money is not there to complete the well. Just got enough money to be able to drill the well. But why? So why early on? So that the significance and changes in specific capacity can be determined. The transducer should be installed by the pump company at the time of the well completion. And that gives us, and if anything, that if any of you have a well that's being drilled, even if you can't complete the well at the beginning, get the level, the data logger in there, and get recording those. And it doesn't have to be anything convoluted. It just has to measure what's happening in the well for that new well. So the calculation, the pumping rate, the static water level at the start of the test, pumping water level at the end of the test, and note the and then you're going to have the determination or the duration of the test, the time, and then the calculation is the pumping rate divided by the static water level. So operation and maintenance. This is a tough one for a lot of you because of the money situation of what you're charging your customers are to how much it costs to rehab a well. But the operation of domestic drinking water wells generally consist of routine monitoring record keeping. It is the operator's responsibility to observe trends and to be able to identify changes in the pumping performance, so the aquifer levels and the water quality. And most operators have to take this anyways for their part of their compliance anyways. In addition, the operator must ensure proper pump and equipment maintenance of the system as per the manufacturer's specification. Again, we're trying to install the pump to match the water flow to get our most efficient pump out there so that we're not oversizing our pumps that will just cost you more in operating costs. So furthermore, the operator should become aware of any potential emergencies and be prepared should a situation arise. So well performance indicators, again, the reduction in the yield, the changes in the water pressure, the corrosion, changes in water quality. So one thing to watch for is definitely the color, sand or silt, dissolved gases in the water, or some of you actually have monitors on your systems where you actually are measuring the amps of the pump and of the motor, and that'll determine if we're getting out of the spectrum. So the failing of the well, so basically the structure fail down, which is the casing or screen. We don't see the screen fail too much, but we definitely see the casing fall apart. Pumps break down. Are we changing these pumps way too often? That's a big one. Is there a problem that's been overlooked? Over pumping, excessive drawdown, as I was saying before, we don't want to. We're always going to get that cone of depression, but we don't want to go past that. Aquifer depletion, well interference from another well, incrustation, corrosion, the fouling, which is biofouling of could possibly manganese or iron. Sand or silt is coming through the well that didn't show up when the well was drilled. Then again, contamination, and then watch, like I said, shortening of equipment. So one of the most common causes of a well failure occurs when water is withdrawn at a faster rate than the well was designed for. Usually what happens is this well is actually now starting to show signs of problems. And what happens is we increase our flow if we can, which causes problems increase if the pump is replaced below the well screen. So we've actually installed a pump deeper, and water is drawn down below the top of the screen or slotted portion of the well. Pump installers will do this if the customer can't afford to drill a new well at this point, and we want to get a little bit more out of this well, so they'll actually install the pump a little bit deeper. But what it does is it speeds up the process even faster of a well failing. So this leads us into well maintenance. Preventative maintenance is essential to ensure a safe and sustainable water well supply. It consists of regular inspections, the monitoring and treatment combined to prevent the premature deterioration of a water well infrastructure and water quality. The best preventative maintenance programs start with the proper well design and construction. And our company, for instance, does this right at the beginning. We actually start you with a new program as soon as the well is done. Other companies do it as well. It's important to you to, as the well operator, to have these records right at the beginning. So schedule preventative treatment assists in controlling anticipated well problems and in maintaining a safe and sustainable water supply. The costs associated with implementing preventative maintenance should be seen as a necessary expense in protecting the investment. The one thing about that I'd add to that is, in a lot of cases, you know, a large well, to drill a well can cost somewhere between $500,000 and $1 million now. And rehab every 5 years on those wells can cost you $25,000 to $30,000 for rehabbing. So there's a huge amount of savings in a period of a well. So it reduces the operation costs, which everybody likes to see. Your bean counters like to see. So if we do that, we reduce the pumping costs, eliminate or reduce the frequency of extensive rehabilitation efforts, and reduce interruptions in service and emergency costs. Nobody wants to go through emergency costs. So inspect your well. If you've got a well, these are simple things that should be done on a checklist that you should have, and most of you probably do. It's whether you're doing them or not, but they're simple things, so just add them to your checkoff list and get them done. So make sure that well tag is there. Make sure that if you have the well tag and that you go into the government well website and make sure that that well is actually registered. Not that you would hope that the tag was put on and it wasn't registered, but go in and do your due diligence and make sure that that tag is actually registered with the government. Well cap is secured, so we don't end up with spiders blocking the vents and stuff like that. The one thing about if the vent is blocked, do not use any chemical, especially like a spider spray or something like that. It contains a chemical in that a small amount getting into a well just through condensation can contaminate your well. There are no open gaps around the well on the outer side of the well casing. There's no ground settling, water pooling around the well casing. We want to make sure that they're built up around the well. Potential contamination sources being that people aren't storing things too close to the well. Make sure that if you have a pump house, that only pump-related equipment are stored in that. You don't need to be storing any of your diazonon and different chemicals in there. The pump, pressure tank, and the water treatment system are operating properly. And again, your septic is operating properly, and nowhere near that your well. If you discover an old abandoned well, seek advice from a licensed well contractor. We can go through the process with you on how to close that well off. which is required if a well isn't being used after 5 years, it must be decommissioned. So monitoring of the well production. So again, hopefully operators have most of this stuff as one of their tools in the tool bag. Is the date and time, note any changes to the static water level, collect and record operational data, note any changes in the pump amperage. You're not going to see too much in the pump voltage, but you may have an electrician that wants to follow up with the nameplate rating on the outside of the motor to make sure that you're within those specs. Conduct a well pumping test to measure the specific capacity of the well. And then on top of that, make sure that those bacteria samples or water samples are taken at least at a minimum of 2 times a year. And then test for, and then make sure that if you're taking those samples, that you look, have somebody look at the nitrates, the sodium levels, the iron, and the manganese levels. Those are the ones that cause those biofouling down in your well. And then test for other chemicals if you have concerns with if there was a fuel spill in the area, or some other, a spraying company came into the area and went on your property without permission. Ensure backflow prevention devices are in place and functioning. And a backflow device can mean that it can be put in place, but it's never been inspected after it was installed. Make sure that you get on to having those inspected too as well. The production against contamination. Maintain at least 3 meters of an area, a grassed area. Like, make sure that those areas are good around the area, that we're not having any, like, the worst that we can see is somebody has paved around a well. Well, pavement has oils in it. We don't want concrete around there. If it's any of the new kind of concrete where they've added different things to it, like, make sure that it's clean, absorbent, and that water can go away from the well. And so ensure potential contaminations are located down gradient of the well. Avoid chemical application, pesticides, fertilizers around the well. Locate and plug any nearby abandoned wells or test holes. Best time to sample your well water is when there is the greatest chance of contamination. So, obviously in the spring we have spring runoff. You guys are know about what happened with bacteria getting into well from fecal contamination from cattle. We all know that one. In the fall rainy season, when we have those long dry spells, and make sure that after those ones, the ground, as you've all seen before, the ground can all look cracked and stuff like that. Those are great places for those contaminations to get into around your well. After a heavy flood, heavy rains, if anybody is down in the Merritt area, we had a lot of wells down there that were contaminated due to the major flood that happened last fall. Those wells have to be looked at. So make sure that you're doing your due diligence by taking those water quality measurements. And then again, wells that haven't been used for a long period of time, make sure that we get onto those too, and make sure that we do our water quality monitoring. So well inspection, we do this on a regular basis. A very expensive camera goes down inside the well, and we inspect the whole well from the top to the bottom. We look for incrustation, calcium deposits, the biofouling, which is, we call them the warding on the outside of the well. It's a living bacteria that feeds off of the casing. So we look for iron, bacteria, and manganese. We look for a breach in the casing. A lot of times those warts will get so bad that they'll eat a hole right through the outside, right through the casing, and right into not an aquifer place, which allows for contamination to come in. we go into the screen. We look for sand coming through the screen that may have been, the screen might have been oversized at the beginning. And we may need to go in and bail those out. Milky water, you guys in different areas in BC might see that as calcium precipitates out, you'll see like this milky type water. Again, those will come through with the water, but there's a lot left behind and it'll actually build up on the casing. Biofilm fouling as well is due to iron bacteria, H2S, sulfur-reducing bacteria, and manganese. Iron bacteria forms a jelly-like slime. Biofouling occurs when biofilm accumulates. Accumulations are sufficient to reduce the water flow. In this picture right here, describes where just below his hand there, or her hand, it shows that the screen is almost completely 100% plugged off, and the only way to remove that in a screen inside the well is through acid. So cleaning method, we go in and we brush the well prior to chemical treatment. The brushing just loosens off all of the stuff that's loose material. It won't remove anything that's really hard in there. We'll agitate the well with a tight-fitting surge block or brushes. This dislodges material softened by, and then this is at the time that we'll add the chemical inside the well. This has to be done by a professional. These chemicals are very strong. We got to go in there and break this material up. So you can imagine that we have to be completely geared up and add a high concentration of chemical to the well. This dislodges material softened by the chemical treatment and pushes the chemical solution further into areas it may otherwise not be able to reach. So we'll actually surge this chemical into the aquifer down behind the screen. We'll monitor the pH. We'll take periodically checks of the pH and make sure that it's below 3. Because as with pH levels above 3, the acid loses strength and doesn't do anything to what we're trying to remove. So we'll check the pH after each agitation. We may have to add the acid more than once during our cleaning, and may leave overnight and then come back in the morning and do more agitation on the well. So fecal contamination, more than likely this well is going to actually be decommissioned or heavy use of chemical to try and bring this well back. But if a well has fecal contamination, more than likely we can't do anything about it. It's coming from somewhere, and we can't stop it for a long period of time. So microorganisms found in the soil or near the well site can be picked up on drilling tools, pipes, and well pumps during construction. So we just do a light disinfection. We don't want to add too much chlorine to a well because chlorine creates a food source for different products to feed off of, and those living organisms down there love dead material. So, following construction of a new well, following an alteration of an existing well, following well pump installation, maintenance, or repair, when the well has tested positive for coliforms. And we may have to go in and do different ways of not just chlorination. We may have to go in with different types to remove these in a well. So once a well is constructed, like I said, get it completed as soon as you can. Install a transducer on each well, and then do that specific capacity test. 6 months into a new well, or annually after the well's 2 or 3. And get to know your well. Thanks very much, everyone, for being in this, this webinar. Hopefully, you guys got some questions for me, and I can answer them now, or you can go on to info at Central Interior Pumps, and I can get some information to you.
Um, that was an excellent presentation, Blaine. So we have some questions. I'm just going to start off with one of my question. What sort of monitoring should you be doing on a daily basis? What should you be doing on a monthly basis and biannually and annually?
I think the first thing on a daily basis is if you actually are a water operator that has to do checks on your pump house or your well, just do simple checks of the things of making sure the grass is cleaned away from the well and that. So simple things. Don't do anything convoluted on a daily thing. Just make sure that gates are locked around your well. If you have a fenced off area like that. The next thing that I would say is when on a weekly to a monthly, let's put those together because a lot of people do weekly to monthly. I would say get to know your system more to do with your amp load. If you have a way of measuring the amps, then measure. You're probably writing down your actual water flow. So see if those change, and then the big thing is to measure how much water you're using for a given time at that time of that period of time. And then on a yearly basis or a 6-month to a yearly basis, I would say make sure that you're taking your water samples and having somebody look at them. Don't just take them and not have anybody look at them. They're not going to go anywhere. Have somebody actually look at them and see if there's if something needs to be done because of those water samples. And then going, into the presentation of doing that specific capacity test for sure.
Okay, thank you, Blaine. We have a question from William Sulba. He's asking, who interprets the data logger and compensates the data with barometric pressure for a domestic well? Is it a landowner? Is it a pump installer? Or is it a geophysicist?
It can be, it can be almost any one of those ones that you said. The most pump installers that work with data loggers and he was mentioning about the biometric pressure. There's compensation between the two because you have a data logger as well as a compensator that goes together. And those will give you your true measurements. To actually have somebody interpret them, we would do either we would look at that data and download that. A lot of them, depending on what brand you purchase, will give you give you a small amount, not too much. It will give you a small amount of information to trend that well. Based on what's in that data logger is recording. So if the data logger is recording pressure and temperature, you'll get those two numbers. And you can if you find that there's something that's not reading to you right, then have a geoscientist look at it, have a hydrogeologist look at it. He's going to be able to determine if there's something going on with your well.
Okay. We have another question from William Schulba. For a domestic groundwater well, is a pressure tank enough storage, or do you suggest a storage cistern? If so, how much volume? How much volume? Do you treat if needed before or after storage?
Okay, so so first of all, let's look at what a pressure tank is. A pressure tank should actually not be called so a pressure tank, all it does is gives you a runtime on your pump. Manufacturers require on small horsepower pumps to run for a minimum of 1 minute, okay? So that's all they do. That's all that pressure tank does. It's not actually supposed to be used as a storage tank. A pump doesn't like to turn a cycle on and off. That's what hurts pumps. So when we look at what a pressure tank actually does, it's actually not a storage tank. It's only there for the longevity of the pump, okay? Now, determining how much water you need for storage. Storage reservoirs work in a matter of the way that we actually interpret it is 1 gallon per minute in a 24-hour period is 1,440 gallons in a day. So it's a lot of water, especially when we're talking domestic well. If even we run systems on 1/3 of a gallon per minute, and it's more than enough for a house. The old rule of thumb used to be 1 gallon per minute would be more than sufficient enough to operate a house. That is, with the new technology in toilet flushing and wash machines and dishwashers, there's no problem to run a house on a 1/2 gallon per minute if you run a storage system. The great thing about a reservoir is that if you have access to a water truck to bring you potable water, you've always got that there. So hopefully that can kind of answer that question, but that's how storage works.
Okay. And then what about treatment? The other part of the question was treatment before or after storage.
So most engineers and hydrogeologists will always want to treat after. So the water goes from your well into your storage, out of your storage, and then do treatment. Because if it sits too long, and I'm not saying that it's a chlorination situation. Chlorination should always be able to inject chlorine and go into a previous before into your storage, so that we kill any bacteria that's in it. And some operators actually have to do what they call batch chlorination, just because we can't put enough chlorine in for how much storage is there. So you got to be really careful. On a residential system, we always pump the water into the reservoir, pull the water out, tell the person that they should be cleaning the reservoirs either annually or biannually. So.
Okay. Thank you, Blaine. Another good question we have is there a chance of biofouling in a monitoring drop tube? Would the water in the tube become stagnant since it's separated from the production tubing?
We're met with a tube. We're only measuring pressure. We're not measuring actually the biofouling of the tube. If that is that the question that they're leading to? When the pressure transducer is in the well, we're only measuring the pressure against the transducer, which with the height of water puts pressure against that transducer. Am I reading the question right?
Well, they're basically talking if there's, the monitoring drop tube,
Yeah.
if there's a biofouling in the monitoring drop tube.
Yeah, we're not too worried about that
Okay.
biofouling in the drop tube. We're worried about the biofilm or in the actual case, inside the casing itself, all the way down and then into the screen.
So, but when you're doing a clean, you are also cleaning the drop tube as well, right? So
It's usually very limited that's inside that drop tube. We're more concentrated on what's inside, and then what we do is we just do we actually introduce chemical through that kills that bacteria in that tube.
okay. What kind of downhole well treatment can be undertaken by a well owner or an operator who's not a registered pump installer, driller, or a geoscientist?
I don't think I'm going to be able to recommend anything because the problem is we're very limited to what we can purchase over counter. It used to be the old way that the groundwater, in government would always recommend to chlorinate your well on a periodic basis. The only problem is if you just do a cookie cutter method, or follow theirs, is we actually end up with too much chlorine in the well, and we actually kill that bacteria, which ends up down at the bottom of the well, and now we actually end up with a food source which creates more bacteria. So it works very short period of time. So as in a homeowner trying to actually do anything with his well, it's the government regulates chemicals to limit what goes into, for people to purchase. So it's really tough for me to do that.
Okay.
Yeah,
But as per groundwater protection regulation,
yeah,
no work should be done by an operator or an owner going into the casing and going down holes. So
no,
anyway,
you're right.
yeah,
Correct.
yes. Okay, we have another question from Sandra Ungerson.
Okay.
She would like to know your thoughts on hydrofracking and subsequent contamination impacts on groundwater sources.
So hydrofracking that's done in the oil industry is completely different than hydro fracking in a water well. So when they talk about hydrofracking in a water well, all we're doing is we're actually just opening up the fissures to allow the water into it. When we talk about hydrofracking in gas and oil wells that has been under huge scrutiny over the past few years, is that um, what we do is when they go into hydrofracking on a gas or oil well, we can actually cause those fissures to become quite large because they're after the gas and oil well. Well, what does it do? It also allows the water to become contaminated in that area as well. So if we go into a low producing well right at the beginning and we know that the well is low producing and we can go in and just do zone impact hydrofracking, there has been some success for it. But as in the oil and gas industry, and we're starting to see what's happening up, especially in the northern part of the country, it's something that's definitely you know, an area of concern. And for sure, I've been asked to sit on a panel as well. So
But do you think, but remember in early on, you could, when you were doing well development, you could use a dynamite, but that's not allowed anymore. So we are slowly heading away from any sort of fracking when we're doing well development anyway.
well, yeah, we are and we aren't. We can still do a small percentage of to open those fissures to allow the water to come into the well, but we don't go in and do it like on a the same procedures that they do in oil and gas wells. We're just trying to open up the fissures just so that we can get the water to flow a little better in a low producing, and these are all done in rock holes. These are not overburdened holes. Yeah.
Okay, thank you, Blaine. We have another question from Angela Story. How often would you recommend a below grade inspection? Would you recommend a set frequency, i.e. every 10 years, or is it acceptable to base the frequency on indicators from your regular monitoring activities?
Okay, so first that one, you know, knowing your well and knowing if there's a problem with your well, that's the first indicator that you're going to need to have that gear pulled out and have an inspection of your well. So that's the first one. So get to know your well, and then if there is something that arises, then that's when you definitely need to have an inspection. A lot of our bigger clients, they want to, every time that pump is on a regular changeout period, because they actually set up money to have those the pump and the motor changed after, say, a minimum of 12 years. They may even go as early. We have one customer that they rotate everything on 10 years. They actually do a camera inspection at that point. And that's also led up with they take on a regular monitor. So they're very proactive in moving towards to make sure that when they got a rehab that they do that. This is a well system of about 14 different wells. They got to stay up on top of them. So for a one or a two wells type system in a commercial application, at a minimum, they should be doing that well inspection. I would say every 5 years.
Okay, thank you. We have a question from Cooper Husband. How effective are well screens at keeping out sand, silt, and clay?
Okay, say that one more time, please.
How effective are well screens at keeping out sand, silt, and clay?
Sand, silt, and clay, there's no screen that'll pull those out. You have to actually pump those to surface and then pull them out at the surface. Um, it's the problem is if the sand is coming from somewhere, it's probably coming. It's always been there. It's the water the development of the screen at the beginning of the well was maybe not developed long enough, and so now those silts and sands are starting to come through. You can't do anything about clay or silt. They will eventually come through the well, and you'll have to treat them at the surface.
We have a question from Paula Gray. If a well does not have a surface seal installed before regulation requirement, would you recommend this gets installed?
100%.
Yes.
We do that, like we work a lot of. First of all, we work a lot with First Nation places, and it became a requirement a few years ago that any well that was still in operation that wasn't a new well is that we dig down, definitely below the pitless adapter or to where we can pick up something that's solid, and then we bentonite and seal the well back up to surface. So yeah, any well that doesn't have it that was previously done, and especially in a commercial application, or it should be done for sure. It's a due diligence thing for sure.
Okay. And this should be done by, again, a well construction qualified well. Okay. All right.
Yeah, so
Uh,
any work related on a well has to be done by a professional.
okay. Thank you. Another question from Jay Goudreau. Can you recommend a supplier of transducer and our data logger?
There's quite a few of them out there. I mean, Solence is a big one. They're from back east, and Huron. They're both Canadian. I'm going to promote them first. They're both Canadian companies, readily available, great people to talk to. And so either Solence or Huron, like I said, you can purchase multiple things off of them. And they're great people to work with for sure.
Okay. And Jay, if you like, you can email me through the online help center, and I can provide you with links and so to the recommended companies that Blaine has just recommended. Okay. Uh, William Schulba is asking another question. Is there a chance that a drop tube affects the water quality of the well?
Well, it shouldn't. If it's just PVC, there should be no reason that it's going to affect the well. The only way that it can affect it is if something's getting from the top of the well into that. But once that is installed in the well, everything's chlorinated and properly put in construction of that well. There should be no reason that should ever cause a contamination. And I've never ever heard of anybody saying that, hey, you got to be careful with your drop tube or whatever. Never had any issues with it before.
Okay. Another question is, should those with a sanitary seal, meaning older type wells, change over to a pitless adapter? So,
Well, so the thing is sanitary seal on the top of a well that's inside a pump house is really tough to go to a pitless adapter. Um, the thing is with a pitless adapter, it allows you to not only work on the well away from the building and not worrying about contamination. Definitely get that out of there. Obviously, when we go into some pump houses, I want to ask why people are actually even drinking that water because if things are not looked after properly. The sanitary well seal works as good as what the last person put it on. So make sure that when you go in and you look at the seal and it's actually protected from rodents and spiders and insects and stuff like that, that it's actually installed properly. And that's as good as it can get. But with a pitless adapter and a proper well cap, there is nothing better than to making sure that that well is secure and protected.
Yes. Thank you, Blaine. Another question from Jay Goodrow. I have 2 wells supplying 1 reservoir. I need new controls to balance water draw from each well. I want to update my system. Can you recommend a supplier or information on pump control resources?
Well, there's actually just about every manufacturer of pump supply from, I'll rattle off some names, and I'm not gonna be proprietary to any one of them, but you start off with Grundfos or Goulds or Franklin. They all make controls to do exactly what you're doing. The pump manufacturers over the last 10 to 15 years want to also get into that situation, exactly what you're trying to do there, Jay. They want to be able to not only supply the pump and the motor, they want to supply your whole system. You go online to any one of them, they will be able to help you out for sure. Those companies want to sell for sure.
Another question from Trisha Wilson. If a company is seasonal, is it advisable to disinfect the well at the beginning of every season? And I think, Blaine, you have to explain about disinfecting with chlorine or getting the well ready, cleaning the well with other products. So if you
So
could really clarify for everybody.
sure. So you're exactly right. There's a lot of seasonal properties out there, especially with resorts, in relation to resorts and stuff like that. And especially that they're a lot of times they can be almost off-grid systems too. So the first thing that you need to go in there is start pumping the well before you do any disinfection. You want to start that well by pumping that well, whatever the rate of the well is, for a minimum of 24 hours. Okay, so if the well does 1 gallon per minute, run that well for 24 hours, okay? Take your water sample. And then now I realize that you want to make sure that the bacteria side is gone. Well, bacteria, you can buy bacteria kits that they're not regulated, but they'll tell you one way or another if that well needs to have any disinfection to it. That's the easiest and the shortest way that I can explain it, because if you just take chlorine and you go, okay, roughly this well is this deep, if you don't know your well truly and know how many gallons are sitting in there, more than likely, I hate to say it, but everybody thinks that more chlorine is better than not enough. So that's why we always say that we always really be careful with chlorine, because chlorine or bleach can actually cause more problems in the well. So that's where, and man, if you've got a big high iron problem or something like that, and you add a bunch of chlorine to your well, and you start precipitating even more of that, bringing more of that out, you can cause a lot of problems with your well.
Yeah.
Is that explain enough?
I believe that also answers the next question, which is by Jay Goodrow. He said, I bleach my well yearly with chlorine to kill any iron bacteria. You're saying this is not recommended, or is once a year okay?
I don't know the chemistry of your water. So if you're going in there actually to kill the iron bacteria, I think for the most part, if you're actually trying to kill iron bacteria, why don't you treat it at the surface, right, rather than killing it in the well? Because if you kill it in the well each year, you're just killing it and it's staying in the well. You don't actually remove it. It doesn't actually, when you kill it, and then it goes down to the bottom of the well, and then it starts to pump out. All it does is it causes the screen to get plugged off more and more each year, and all of a sudden, so you've got this much screen that you're pulling from in the end, when you've actually got, like in most cases, a well will have like 5 feet of screen. So each time you kill that off, that just creates a more food source for any stuff that you've done. So because 9 out 9 out of 10 guaranteed that you're not going to kill every piece of bacteria down there. It's going to grow again.
Yeah. Okay. I think we're kind of getting away from putting bleach down or chlorine down our boreholes anyway. So
Yeah,
it's all about acid cleans anyway. That's the direction we're moving in now. So
exactly. Yeah, we try and educate people more of cleaning the wells rather than, and bringing everything to the surface rather than doing it in the borehole, for sure.
yeah, we will have another webinar actually on treating for iron and manganese that's coming up in November. So please keep a note of that and make sure you register for that. That's it for all the questions, Blaine. Thank you everyone for attending. Thank you to Blaine for taking this time out of his very busy schedule to do this for us, do this for the small water systems in British Columbia. If attendees have any subsequent questions, please email it to the online help center and we will send those questions to the speaker, or I will do my best to answer them myself. Your certificates will be automatically emailed to you, so please remember to save them as we cannot reissue the certificate for participation. And please note that our next webinar is scheduled for Tuesday, September 20th at 11 a.m. again. And the next webinar is on water loss and water aging. And our presenter is Michael Furlod. So thank you again for attending. Thank you, Blaine. And we will see you next time. Bye-bye.